Hello everyone, welcome to Geoscience Engineering, and we are continuing the course of seismology. In this video we will be discussing about the seismic stations and the sensors, and in this particular video I will show you the live seismic equipment, the digitizer, the GPS, the sensor and the installation process, and also the installed seismic station. So, as we have already discussed about the seismic stations, and then the classification of seismic stations like permanent stations and temporary stations, and then we also discussed about the network types, and then the seismic components, and here we will go into a detailed discussion of every component. So if you see this video, this is a seismic station. Here when you see, this is powered by a solar panel, and it is having an antenna to boost the internet signal, and there is a GPS, and this is a permanent station which is constructed with a shed so that it won't be affected with the rain and more heat, and this is how the installation will be. And if you see here at this particular place, this is far away from the road, and there is a little forest. So this is a station which is far away from the disturbances, and the solar panel is faced in the proper direction so that the battery is continuously charged, and in the night the battery will be giving the backup to the instrument so that there won't be any gap in the data transmission. Now here if you see, this particular solar panel and the antenna are all mounted on a pole, and from there we are connecting it to the station. Now I will tell you the second component, that is the GPS. Here you see this particular thing is a GPS which will give you the lat long position and also the time, so that when there is an event taking place, you will get the graph with the time and with the date, and also with the magnitude and all. So the processing of the magnitude and the direction we will discuss in further videos. Now we have a closer look at the seismic station. So in this seismic station you have a 12 volts battery. This 12 volts battery is the source for the running of the instrument. So when the solar panel is on during the day, this battery gets charged, and in the night or during the cloudy season or when there is no sunlight, this battery will give backup to the instrument. And you can also see there is a router that is connected to the instrument. In that you have a SIM card. So this is one kind of GSM based telecommunication setup, in which you will be adding a SIM card, and that SIM card will provide the internet facility, and the instrument is then sends the data to the server. And you can also go for the different kinds of telemetry systems like VSAT, that is very small aperture transmission, or you can also use the satellite communication, or you can directly use the LAN system for data transmission. And this router is giving you the data, and without this the data will be only stored in the instrument and it cannot be retrieved to the system. And here you can see the digitizer in which the data will be recorded, and this is particularly faced in north direction. I'll tell you why we have to install the instrument facing in the north direction in the coming videos. So this is how a setup will look like, and this is the installation part. It looks messy, but this is what how it looks like. You can also go for a wider containers in which you can keep everything wide. And next I will discuss more about this permanent seismic station, and then we will go back to each and every part separately. So in this, when we say the most critical aspect of the seismic station is sensor installation, particularly for broadband sensors. uh, sometimes like when you are going for a very long period, that means recording the signal for more than 10 hours or even for months and years, you'll use this. First important thing is the geographical location of the seismic station. So when we are going for the installation, we need to take into consideration about the geography of that particular area, and then the power supply. So here is the power supply, and here you have the battery source. So the power required for this equipment is generally 1 watt, and sometimes when they are high capable and high power usage, then you will have to go for even 100 watts also. That depends mainly on the station, and usually these are installed in remote areas where you don't have the power access, so people go for the solar panels. And then communication is also very important. Sometimes you have satellite communications, and sometimes you don't have that satellite communication, then you need to go for the radio transmission. And sometimes you can directly go for the power supply or the internet supply from the nearby towers, like the service providers of Airtel or BSNL you can do. And most importantly, this particular station should be far away from the noises that are made by the humans. So you see this vegetation here, this vegetation is just covering, and there are no any kinds of vehicle movement or human movement at this place. And this fence is also made to avoid entry of any animals in this. And then the access is also very important. Sometimes if there is an issue, you need to go to that place and then do the maintenance. And especially in weather, it should be avoided with the lightning more, because lightning will damage all the solar panels and all. So you should make sure that that particular study area is having minimum lightning. And also the geology, which is very important, because it is well known that sensors on soft soil will give more noise than sensors on the solid rock. So generally what we do is we avoid the soft soils. And when it comes to the site selection and also the seismic noise survey, a seismic station should be located on solid basement rock that can be expected to have a lower noise level than the station that is on the soft sedimentation, because noise will add more disturbance, and that will create more irregularities in the data. So we must make sure that this is not happening with the seismic stations. And after that, when you go for the installation also, during the seismic installation, there are few things to be considered. One is the sensor installation. I will show you the sensor first, then we will discuss about the sensor and its installation part. So this is the sensor. We call it as a geophone also, and this is especially for borehole installations. So that is why it is very rugged. It is covered with a complete container in which you have the detecting coil and all, and this is connected to the instrument. And this is giving the data analog, and that is being converted into digital signals in this digitizer. And this is how the sensor will work. So we have installed this at 5 meters depth. It depends on the cable length also. If you go for more deeper, you can have an extension of this cable, and this cable you can use for more than 10-15 meters also. The deeper you go, the lesser the noise you acquire. And this particular station, the geophone or the sensor, this is having a 3-component sensing capability. So this can gather the information, or it can receive the information and show you from which side the wave has arrived. Is it from the north south or east west, or from the vertical direction? In the coming videos I will show you the particle motion which is recorded by a sensor, that you can see it in the graph. Now we'll go more deep into this sensor. So when it comes to the sensor installation, there are many things to be considered. Sensors are generally made of some hard plastic or stainless steel, or sometimes made with hard metal, so that they are not affected with the rust and all. And when it comes to a borehole sensors, that means the broadband sensor something, that they need to be installed so that even a small disturbance should not move them or disturb their setup. So that is why we usually go for a installation in which we will go for the pipe. So the sensors are fixed in the like casing like this, again the pipe, so that it won't be damaged with the rust and all, and no groundwater or any other moisture enters into the pipeline. And once this is fixed, this will be fixed into the ground, and then there will be a wire, so that you, if you want to pull outside, you can easily pull it. And this is how the setup of the installation. First the sensor will be pushed into the ground and it is fixed there, and after that the digitizer and all those things will be considered for the connections. And there is an also important thing to know, that the sensor also faces the north direction. This is because I'll tell you why we are focusing more on the north direction. So this is how the insulation look like. So first you insert this into the pipe and then put it in the ground, and make sure it is facing the north direction, and then you fill with some solid material, and then you cover it with the casing. And from there on the top we will have to put the digitizer, the battery, the charger, the battery, the converter, and the Wi-Fi router and all. Next we'll go for the description part. So as you are seeing here, these stations, the sensors are generally fixed into some kind of a external covering, so that no other moisture enters into these. And once this is done, we will be burying the sensor into the ground, and we also face the direction of north. And also explain why we have to keep this in the north all the time, the sensor and the instrument, the digitizer. And then finally we'll cover with some soil, and then we keep the casing on the top, and in that casing we will get the digitizer, the battery, the converter for the solar to charge the battery, and then we have the Wi-Fi router or the router for internet access. Next I'll give you some description about the theory about this one. So in the particular case of installations, there are a few considerations to be taken. Uh, Firstly, we need to know about the purpose. Are we going to install this for a longer monitoring, or we wanted to go it for a shorter time? If you are going for a long monitoring, you don't have to do the casing for the sensor. But if you are going for a shorter one, you need to definitely make sure that it is not permanently fixed inside. And this is a permanent installation in which we have added the cement also, to make sure it won't be next subjected to some theft or robbery. And when we have the very long period seismic station, we should have few considerations, in which the lightning or over voltage protection should be taken care. And then when you have the noise level more, we need to make sure that this is installed even more deeper, because sometimes when the sensor is installed in 1 meter below the ground, you may or may not have the disturbance, and if you have disturbance you need to go for deep. So the ideal installation depth would be approximately 5 meters. And then regarding the power sources, mostly we are using the 12 volts battery and also an AC 12 volt supply. So this battery gets charged all the time, and then there is no disturbance or break in the data transmission. And mostly when we are using for the batteries, we can go for a dry cell battery, or we can go for the lead acid battery, or we also go for the lithium ion batteries. But make sure these batteries have more capacity, and they are self discharging, and the battery life is also high, because once you install the seismic station, you may or may not be having the time to go check the batteries and all every time. So that would be good if we have a little longer duration batteries with longer life. Now this is part of seismic sensor. In coming videos, I will also explain you in detail about how a seismic sensor works, and how a seismic sensor is made, and what kind of circuits are used in this. Now we'll go for the seismic digitizer. So now we are looking at a digitizer or a recorder. This is the most crucial part in a seismic station, because this is having all the programs, and this is having the storage. This will gather the information, and it will convert the analog into digital, and this will be sending the data to the server, and this is giving the power to the seismic sensor. Now if you see the working, so we have a source for the input power, that means to power the instrument, and this is for the GPS. So when you connect an external GPS, that GPS signal or the latitude longitudes will be taken care by the digitizer. And there are different kinds of sizes also. Some are handy, some are big, and some are wide also. And the regarding the storage, there are two things. One is, these stations can directly transmit the data to the server through some portals, or they have an internal storage like a memory card or a USB stick, so that the data will be stored in those sticks. And when you don't have the access to go for an internet, you can at least use these pen drives to manually copy the data and then go for the further processing. In most of the short time surveys, or where you have some seismic micro resonation, people don't go for the online servers and all, so they directly take this particular digitizer and keep it on the ground on a level surface, and then they collect the data, and then that will be stored in the pen drive, and that will be taken, and it will be taken for the processing. Here these equipments are also containing accelerometer, so these equipment will take the seismic data and also the acceleration data. So these are used for both structural analysis and also earthquake monitoring, and also further studies. Now I'll give you a theoretical explanation about the digitizer first. As we are discussing about the seismic recorder, seismometers give out the electric signals, and to preserve these signals we need a device for permanently recording them. Since these seismometer output signals generally are very small, and they also contain noise, so they have to be amplified and also filtered before recording. This is called as analog signals preparation. So in the simple way, a recorder is any device, that means this particular device is a device plotting the signal in a permanent way, just like a chart or a drum recorder, and we get the seismogram. The present most common way to digitize the signal with an analog digital converter and record it in some computer device, we are using these digital digitizers. This is a set of recorder and a sensor, and both of them included we call it as seismograph. So without the sensor and without the recorder, there is nothing like seismograph. So you need a sensor, you need a GPS, and you need a digitizer, then only you can call it as a seismograph. So the recorders are again divided into portable low power units and also large high power units for permanent installations. The one which you are seeing right now is a portable unit. The recorder must also uh, take care of few things other than recording the signal. It should also take the signal from the GPS and maintain the time so that the exact event will be known at what time. So the availability of this GPS signal is also very important. When there is no signal from the GPS, you may be getting the data, but you are not able to get the exact timing. So these are also very important things. And the most important difference is that the field recorders must be designed for portability and also low power consumption, because when you have installed this equipment in some remote areas and the battery is 12 volts only, and when this is consuming more power, you may not be able to get a proper data, and there is an interruption in the power source all the time. So in the coming videos, we'll discuss about the complete working principle, and if possible the internal structure of a digitizer we will discuss clearly. And from the coming videos they will be very interesting, which contains about the seismic networks, the purpose of seismic networks, what is the geometry of the network, and the network configurations, and the radio links, the seismic data transmission, and also the arrays of seismic that are being used. And we'll also discuss about factors related to the sensors, that means sensors damping or sensor free period. And we'll also discuss about the corrections of instrument response, and then we'll go for in detail description about the calibration of the sensors and the accelerometers and the velocity broadband sensors, and also with some examples. And we'll also discuss about the seismic noise, which is very important in analysis. So we discuss about the seismic noise and the noise spectra and the origin of seismic noise, and the uh, process of removing the noise and identifying the wave formats and identifying the P wave, S wave arrivals, and then also how to find the phase differences or the phase structures in the seismic waves, and other but important things we'll discuss. So here, as you have seen this one, and I'll also show you the video for GPS. So this is a GPS. These GPS are small and magnetic in nature, so you can directly stick it to the metal surface, and these are connected to the seismic stations, and these will continuously give you the time stamping. So these are also very important in acquiring the seismic data. So in the next coming videos, I'll explain you everything in more detail, each and everything in detail, including the circuit diagrams or the way how the digitizer works, the way how the sensor works and all. So if you like this video, please like it and share to your friends. And if you have any comments or queries regarding this, please do post a comment in this, and do subscribe to Geoscience Engineering channel, and check out the other videos related to the electrical resistivity, seismic method, magnetic method, and other geophysical and remote sensing techniques also. Thank you.